Welcome back, viewers. Today we want to look at the external division of 2 points in a vector using the ratio theorem. Now in question 10, given that OA is 3i plus 4j minus 7k and OB is equals to 9i minus 5j minus k, and that R divides AB externally in the ratio 5:2, find the coordinates of R. In the other question related to this, find the magnitude of vector AB above. And then in the other part, that is on vectors though not related to ratio theorem, you're told to show that points A 1, -1, B 3, 5, and C 5, 11 are collinear. So we're going to start with the first part, and allow me to go back to the concept of ratio theorem. Though in the examination setup you'll not be required to show all this, I'm only doing it for the sake of our revision exercise and any other question that may come related to this. Now we have two vectors A and B and a point that divides the vectors externally. So on the Cartesian plane, we can present these vectors that can be presented by vector A, and then there's another point here that can be represented by vector B, and they lie on a straight line. If R divides them externally, they lie on a straight line, so that we can have point R, and this is represented by small vector r. From the statement given, R divides AB externally in the ratio 5:R. Therefore, from A to R, we have 5 units. A to R, 5 units. And then because R is external to AB, R is external to B, from R to B, moving in the opposite direction, we are going to have -2 units. And then from A to B, we are going to have 3 units. From the statement, or from the division 5, the ratio 5:2. That is what it means. Therefore, from our previous knowledge, we just want to express OR in terms of AB. OR will be given by, what path do you take to move from O to R in terms of A and B? It will be given by OA followed by AR. OA followed by AR. And OA is given by vector A. So AR is given by plus 5 out of 3 parts of vector AB. And what is vector AB given by in terms of small vector A and small vector B? AB will be given by vector B minus vector A. So OR here will be given by small vector A plus 5/3 into brackets vector b minus vector a. When we open the brackets, we're going to get this will be equivalent to vector a plus 5 over 3 vector b minus 5 over 3 vector a. When we collect like terms, this coefficient here is 1, so this is 3 over 3 vector a minus 5 over 3 vector a. So OR will be given by negative 2 over 3 vector a plus 5 over 3 vector b. And that is the position vector of OR itself. Now, using ratio theorem, then it would imply that the position vector of the point OR is given by negative 2 over 3a plus 5 over 3b. Now let's go back to our question. We want to find the coordinates of R. Now, OA, we know that OA is given to us, and we can express OA in terms of a column vector. OA now will be given by 3, 4, negative 7, like that. And then OB will be given by 9, negative 5, negative 1, like that. So we've expressed this in terms of column vectors. Of course, OA will be given by small vector a, and OB would be given by small vector b. Now, so we go back to our theorem on external division, and we are going to get this now as the position vector of OR. First of all, we need to get the position vector. So the position vector of OR will be given by negative 2 over 3 vector A plus 5 over 3 vector B. And since we know the column vector A and B, we just come and substitute. We need to come now and substitute. We are going to get negative 2 over 3 multiplied by the column vector 3, 4, negative 7 plus 5 over 3 multiplied by the column vector 9, negative 5, negative 1, like that. So when we multiply this, negative 2 over 3 times 3, this gives you negative 2, and then negative 2 over 3 times 4, negative 8 over 3, and negative 2 over 3 times 7, 14 over 3, like that, in terms of a column vector plus 5 over 3 multiplied by 9, that gives you 15. 5 over 3 multiplied by negative 5, that gives you negative 25 over 3, and 5 over 3 multiplied by negative 1, that gives you negative 5 over 3, negative 5 over 3. So when we add this, we are going to get the column vector 13 negative 8 over 3 minus 25 over 3 negative 33 over 3, which gives you negative 11, and finally 9 over 3, 14 over 3 minus 5 over 3 gives you 9 over 3, which is 3. So that is our column vector, but our question asks us to give the coordinates of R. So we need to give that as a coordinate, and we are going to say that R, the coordinate R, will be given by the points 13, negative 11, 3, and that is our required solution. So that is the coordinate form. Now, as I told you earlier on, this part here is not necessary in the examination room, but I just wanted us to go back and remind ourselves so that we can enhance our mastery, content, or skills on the external division of a point. In part A, we are told to find the magnitude of vector AB above. Now, if we want to find the magnitude of vector AB, the position vector of AB would be given by the vector OB, minus the vector OA. The vector OB minus the vector OA. And the vector OB in terms of a column is given by 9, negative 5, negative 1, minus OA will be given by 3, 4, negative 7. So when you subtract this, you're going to get 9 minus 3, that gives you 6, negative 5 minus 4, negative 9, and negative 1 minus 7, negative 1 plus 7, which gives you 6. So we now have the column vector AB given by 6, negative 9, positive 6. So to get the magnitude of vector AB, or the modulus of vector AB, the modulus now denoted by that will be given by the square root of 6 squared plus negative 9 squared plus 6 squared, all that under the square root sign. So this will be given by 6 squared gives you 36, so the square root of 36 plus negative 9 squared 81 plus positive 6 squared 36. So when you add this, you can take your calculator, we confirm together, you're going to get 36 plus 81 plus 36. That gives you the square root of 153. And the square root of 153, this is approximately equal to, again, take your calculator, feed in the square root of 153. That will be approximately equal to 12.36 approximately equal to 12.37, and that will be your answer. And it is important, at times you may be asked to give it correct to 4 significant figures, 2 decimal places, and it is up to you to adhere to what the examiner requires from you. In part B, you're told to show that point A, 1, negative 1, B, 3, 5, and C, 5, 11 are collinear. Now, what do we need to remember about collinear points? If points are collinear, it means that they lie on a straight line. And one, we need to show that first, the 2 points are parallel, meaning that you can express one point in terms of a scalar multiple of the other point, and then 2, you need to show that there's a common point that exists between those points that is given to you. Now, we have point A. We want first of all to show that those points are parallel, and then we shall come and see whether they have any scalar that multiplies one displacement point with the other to show that they are parallel, or express them in terms of a scalar multiple. Now we have A can be written in terms of a column vector. B can also be written in terms of a column, and C can be written in terms of a column. Now, in this particular case, to show that they are parallel, we need to get AB to be equal to a scalar K multiplied by BC. AB to be equal to a scalar K multiplied by BC. Let us see whether this condition can be satisfied. So B in terms of a column, or the displacement from A to B, would be given by B minus A. So this will be given by 3, 5 minus 1, negative 1, like that, to be equal to the displacement between B and C would be given by C minus B, 5, 11 minus 3, 5, like that. So when we subtract this, we're going to get 2, 6, we're going to get 2, 6, to be equal to 5 minus 3, this will be equivalent to 2, 6 as well. And in this particular case, if we go back to this expression, we've already gotten this as AB is equals to KBC. So we're going to get 2, 6 to be equal to K multiplied by the column 2, 6. So this implies that 2 will be equal to 2K, and K here is equals to 1, or 6 will be equal to 6K k is still equal to 1. So the value of k here, this implies that AB is equals to 1 multiplied by BC. And since AB is equals to 1 multiplied by BC, it implies that AB is parallel to BC. AB is parallel to BC. And the first condition is already satisfied. They are parallel points. So the second thing that we need to come and say, since AB is parallel to BC and B is a common point, we need to make that conclusion. AB is parallel to BC. AB is parallel to BC, and at the same time AB is equals to a scalar k multiplied by BC, and AB is equals to a scalar k multiplied by BC, and B is a common point, hence collinear, and B is a common point, hence A, B, C are collinear points. So that is how you answer that question in case it comes to you in the examination.